Thank you, Brady. I've been talking for like a minute and a half. So we're looking at our learning target for today. I can find the rate of change of a linear relationship by figuring out the slope of a line representing the relationship. So I'm going to give you another 10 seconds. I'm going to give you another 20 seconds to find the value of 2 5/8 divided by 1/2. I'm looking for a final answer here, my friends. Take another 20 seconds right now. Find the solution.
I didn't say anything. Well, how may that be wrong? And give an answer. I don't.
Thank you guys. I knew you guys could do it. Okay. Oh. Let's hope she stays. Let's try something. Okay, we're taking 5 more seconds, and then we're coming back together to discuss how would we solve this. Well, there we go. Okay, so my friends at home, make sure you're getting an answer here. Throw those answers in the chat, and let's take a look. Okay, so we have to find the value of 2 5/8 divided by 1/2. What is our first step here? Hazel, what'd you do first here, my friend? Good. She made it into an improper fraction. Who can help me by telling me what's the improper fraction going to be? Melina. Very good, because you multiply the whole number times the denominator, and then you add the numerator. That's like really not aligned, but it's okay. So we multiply 2 times 8, get 16, plus 5 more is 21/8. And then what do we have to do? So it's keep, change. Oh, wait, no, so we're going to say divide by 1/2. Keep, change, flip. Very good. So we would have to keep our first fraction, 21/8, change our sign to multiplication, and flip, or what's the other fancy word for flip a fraction? It's reciprocal or reciprocate. Okay? Can you guys at home hear me now? Throw it in the chat. Reciprocate, which means we write it as 2, thank you, Brady, over 1. Thank you, Eric. So I have keep, change, flip. Now I multiply numerator times numerator, denominator times denominator. What am I going to get, Luke?
42 over 8.
42 over 8, which simplifies to, I'm not looking for an around. Oh, it's not going to go in perfectly. So what's it going to be, Melina? What was it?
5 1/4.
5 1/4. Very good. Did anybody get a different answer? Equivalent, but like different, in a different form. What'd you get, Fizza? 5.25. Very good. 5 25/100. Awesome job, Julia. 5 25/100. You could also simplify it to, oh goodness, half, 42, 21 over 4. You could also write it as 21 over 4. Okay? So, everybody did fantastic. I'm actually really proud because I thought this was going to be a little bit of a sore subject. I know this year, I know that usually this is a pretty tough thing to do. You do it very limitedly in 5th grade. And you do more of it in 6th and 7th, but it's not the main priority. So we learned this all the way back in 5th grade. I'm really impressed with how well you guys did. Awesome job. Okay. Fantastic job. Oh, no, maybe not. Okay, here we go. Okay, so let's take a look at this next piece here. So the next piece of this activity, if you're looking in your textbook, You don't see this exact picture because you actually see the picture that's on the next slide. But what we're going to be looking at in lesson number 4 today is we're going to be looking at stacking cups together. I left them over here. So we have, let me just see where this camera is pointing so that everybody at home can see it also. So we have cups here, right, that are stacked. And if we look at this stack, right, and you look at your textbook, let's look at the different heights in these stacks. So one stack has 6 cups in a height of 15 centimeters. And then the other stack has 12 cups and 23, it is 23 centimeters tall. Wait, did everybody get that? So the smaller stack has 6 cups and the height of it is 16 centimeters. The taller stack here has 12 cups and is 23 centimeters tall. The total stack is 23 centimeters tall, okay? So we have to use this information, this ruler, find some other measurements to answer the question, how many cups are needed for a stack with a height of 50 centimeters? So how can I, I'm confused. What, I mean, I'm not really confused, I'm playing the game. But what do we have to do, sorry. What do you think we're gonna have to do to find out how many cups I need to be 50 centimeters? Landon, what are you thinking?
You have to like find out how many centimeters, like every time you put like 1 cup in, how many centimeters like go on.
Good. So he's saying we're gonna have to figure out, like, when I add a cup, when I add 1 cup, how much height does it add to the stack? And what else do you think we're gonna have to? What do you think? What else?
I already know the centimeters.
Okay, so he already found out what the centimeters was that that we add every time. My other question though is very good, Julia. My other question though is, like, when I have 1 cup, is it gonna be equal to how much it adds every time? No. So we're gonna have to find the height, so some number x, but we're gonna have to add sort of like a starting value. So when we have 1 cup, if you look at the picture, how tall is 1 cup if you look on your picture? It's kind of hard to see on the slideshow because it's like a little bit distorted. But I want you to look in your book. Draw a little line from the edge of the cup over to where it hits that measuring tool and tell me how tall is 1 cup. So looking in your text, how tall is 1 cup going to be, Haley? Okay, so
Really done.
oh, here, why don't I do this? Mr. Maine. Oh, okay, who has it? Jessica. 8 centimeters, yes. So to find the total height of our stack, we have to take 8 centimeters and add to it the number of cups we stacked times how much each stack adds. So how much each cup adds. So we start with 8, right? This isn't really 8, but we're just saying here. We start with 8 centimeters, and then we multiply the number of cups we add times how much height each cup adds. Does that make sense? So let's see if we can let's see if we can write an equation for this. So I have y, which is y equals our height. X is equal to the number of cups. Okay? So my height is equal to the number of cups times how much does each cup add? Look at your image here. How many centimeters does 1 cup add to the height? Jason.
2.5 centimeters.
Let's take a look. So we start at 8, and so we go like 8, and then the next cup hits at not 2.5.
Oh,
it's not going to be 2.5, it's Dillo. 1.5. So we're going to have to multiply the number of cups times the height that it adds of 1.5. But, so let's take a look here. So if I'm looking for when the height is 50, what am I going to plug 50 in for? Y or X? Which one does the height represent? Which variable does the height represent? Melina?
It represents Y.
It represents the Y. So if I want to find out how many cups I need to get to a total of 50 centimeters, we're going to say 50 centimeters is equal to how much each cup adds, 1.5x, because we don't know how many cups we have. We're going to solve for that x, plus our 8. So what I want you to do now is I want you to solve this equation for x. So get your constants to one side, divide by that number attached to your x or your variable, and get a value for x. How many cups are we going to need to add? Once you get the answer at home, throw it in the chat. I'm going to give you another 20 seconds, maybe even 30, I don't know, depending on how much time you need. Brady, Eric, Julia. Brady. Brady, Eric, Julia. Okay. So when I solved it, I want to see if Reese can help us with this one, because I know that Reese is pretty good at solving and like knowing the steps that we got to do. So what was your first step here, Reese?
I subtracted 8 off both sides.
Yes, fantastic job, Reese. Exactly what I'm looking for. Perfect. So I have to subtract 8 from both sides. So what am I going to get now? 50 minus 8 is 42. 42 is equal to 1.5x. I'm done. Nothing more to do. Ooh, okay. Help me out, Melina. What do I got to do?
You multiply each side by 1.5 because it's a decimal.
But it's still attached. Just because it's a decimal, yes, it is a decimal, but it's still attached with multiplication. So you still need to undo it by doing what operation? Division, right? And then when you go into your calculator, you divide by 1.5, divide by 1.5, and how many cups is it going to be? Go ahead, Dylan.
28.
28 cups. See, this always happens. 28 cups. Okay, so listen and watch. So I have to stack 28 cups that add that 0.5 every time. So how many cups am I really going to have on my total pile? Because I have the original cup that has the 8 centimeters, and then to that I need to add 28 more cups. So how many cups do I have total in my column? How many, Melina? 29. We can't forget to add back in that original cup that represents this plus 8. So we need to take this 28 and add 1 to it. So how many total cups are we going to have to get to 50 inches or 50 centimeters? Is going to be 29 cups. Very good job. So this guy was a little bit of a trickster. It was a low key. A low key. He's a trickster. Most of the equations that we solve, when I'm giving you in context, it's not going to require you to have to remember to add one in at the end. It's never going to happen. But this, I wanted to give you something that was a little bit of a trickster because I knew that you guys were going to do fantastic with this. So I was like, let's think of a situation that would add one little bit of a trick to it, a little bit of a hard part to it. Because I knew you guys were going to do fantastic, which you guys are. Okay, so it's going to take us 29 cups to get to 50 centimeters. So let's look at the next piece of this. We're going to be creating an equation for this situation. We're going to be creating a graph. So we have an equation, sorry. We have an equation. Now we're going to be creating our graph. So let's look at the directions at the bottom of this page before I have you flip the page. Whoop. Okay. So, oh wait, I have the pencil out. Sorry guys. This is so blurry. Oh my god. I feel like I'm blind when I look at this board. Okay, so looking at this and thinking about what we know about proportional relationships. Is this stack? Wait, first of all, what's a proportional relationship? Do we remember from last year what a proportional relationship is, or what a proportional graph would look like? Hi.
Hi, can I interrupt you for 1 second? Was this anything for you?
I want to, yes.
Okay, I figured you would.
Yes.
See how I think about other people? So I'm gonna go ahead and teach you math. This
Is it a proportional relationship?
is a right angle.
Okay, give me 3 shades of Lansdale.
Somebody help me here, because now I really feel kind of not smart. Besides it being a right angle, is it proportionate? Is that what she was saying?
Proportional.
Proportional, is it proportional? Just raise your hand if it is a proportional right angle. You think it's proportional? I would agree, because if I took a mirror, or if I flipped it on my camera, you know, you could do that, you could flip the screen, flipped it, yeah. So it would be the same, right? So I'm pretty sure that means proportional. I'm totally winging it right now. I have anxiety around 8th grade math. So
Hey, she's doing fantastic.
am I? Is that
This is
what proportional?
algebra. This is algebra, so it's even 9th grade now.
All right, yeah, I'm leaving.
Yeah, you got this.
So, oh, hey, how are you? Brianna.
Yes.
Oh my God, do you know you have a twin in this building? That's scary. Name Alexis. You didn't know that? Brianna, what's your last name? Yeah, you have a twin. Oh, see, look at, or you can do that, but, ready? Watch us.
Well, okay, go ahead.
But you have to start the line here.
Yes! Yes! That's literally right.
Is
Yes!
that where you were going?
Yes, that was exactly
I
where I
could
was going.
co-teach math.
She could pro-teach math. Like, yes.
I'll take that. You
I'm
can,
so
you
proud
can,
of you.
you can clap for me. It's okay. My self-esteem needs it. All right. Math extraordinaire.
Woo, woo, woo. Let's try it. Woo, woo. Okay.
Okay.
So a proportional relationship or a proportional equation line means that it starts at what point on our graph? Proportionals start at the origin. Yes, fantastic. That was exactly what I was going for. Fantastic job. Thank you for sticking with us on that. So proportional relationships start at 0. She was good when she moved it down there. So if we're thinking about this relationship here, is this gonna be a proportional relationship? What do you think, Pizza? Well, if we look at it, if we look at our graph, right? It would start like at 1, it would have a height of 8, right? So is it gonna start at 0, 0? No, it's not, because when we take our line and we extend it out, it's not gonna hit our axis at 0, 0. It's gonna hit our vertical or y-axis at a point other than 0. If we remember, proportional means it starts at 0, 0. If it's a non-proportional, it crosses our y-axis somewhere other than the origin. Okay? So that's what proportional means. So let's look at and let's try to create a graph for ourselves of this situation. So if we look at number 1 here, it says, if you didn't create a graph on your own for this situation, we're going to do so now. So we're going to do this together. Okay? We're going to find 3 data values, and we're going to plot them and connect them to create an equation line. Well, actually, it's going to go like this. So if we said, when we have 1 cup, if we go over to 1 cup, number of cups, what did we say our height was going to be? What was our y value going to be, Dillo? 8. 8, very good. Okay. And I wrote a y, I meant an 8. Okay. It would be an 8. So I would come over on your graph, you're going to do this. On here, you're going to do this. You're going to go over to 1, up to 8, and you're going to put a little dot. I'm going to have to go in with my eraser just to make it a little bit better. Okay? So now we need to find another data point. Let's look at, for example, let's look at 10, when we have 10 cups, and when we have, how many did we have when he said it was 50? 29. So let's look at, so we know that 29 is going to have a height of what? 50. So I can come on here, I can go, if I want to get to 29 comma 50, how do I get there? Physically, what do I have to do? I have to go over 29 and up to 50. So over to 29, up to 50. I'm going to come right in front of you guys. Sorry, guys. I'm just following this guy here. Let me come back in with my eraser. So I have 2 data points here. Do I have enough to create a line? I have 2 points. So I can use a straight edge or a ruler. Connect our points and to create an equation line. Let's do it. Connect those 2 points to create an equation line. I'm going to get a better one for you guys. This was sort of just spontaneous. There we go. Connect your 2 points. Yeah. So we have our 2 points here. We're going to use our ruler and we're going to connect them. This is going to be tricky because we're not aligned very well. So let's see. I'm overcompensating. Nope, I have to undercompensate.
Good afternoon. If you borrowed a Chromebook or a charger from the library, please return it at this time. Thank you.
That's a pretty shaky line. Not the best. It's pretty good. Thank you. On a unaligned board, it was very good. Thank you. And you know what? Positivity is key. Love it. Thank you, Landon. So I created a line for this equation. So now if we're looking at this equation line, do we think it's going to be proportional? Can we say that this is proportional? No. Why can't we? Jessica, what did we say? Where do proportionals have to go through?
Well, I was going to say that the lines have to exactly the same.
Huh?
I was going to say that they're not exactly the same.
So I didn't really connect them the best, but it's supposed to be a straight line. So yes, Dylan.
It didn't start at 0.
It didn't start at 0, 0. So this guy is not going to be proportional because he didn't start at 0, 0. He's not proportional. We're going to talk about the name that we're going to give this guy in a few moments. Okay. So Reese, you can bring that back down. Bring what you need. And come back up and we can go through the rest of this, okay? Fantastic. So we created a graph. That was number 1. Now we are going to look back at these questions here, and we're going to take a look at 2, 3, 4, and 5. Okay? So what are some ways you can tell that the number of cups is not proportional to the height of the stack? How do we know if a graph is proportional or not? Final answer, Jason.
It starts at 0, 0.
Does it start at 0, 0? Very good. So this should be written in between here for that answer for number 2. I just didn't leave myself enough space. I don't know what I was thinking when I made this. Okay, now number 3. It says, what is the slope of the line in this graph? And what do we think? Has anybody ever heard of the word slope before? What does it mean? My friend, slope is talking about when we're looking at a line. Go ahead, Fizza. An angle, or yes, go ahead, Landon.
Ski slope.
A ski slope, right? So when we're talking about the slope of a line, the slope of the line is talking about the steepness of the line. How steep is our line? And the way that we calculate slope, my friends, is by, on our line, finding 2 points that fall on the line and finding how many I have to rise to get there and how many I have to run to get over from one point to the other. How much do I have to rise? How much do I have to run to get to that new point? I also call it my constant rate of change. So if we're thinking about this cup situation, my constant rate of change is how much I'm adding to my stack each time I add a cup, right? Because that 8 is a constant. It has no variable attached to it. Our rate of change is always going to be attached to a variable. So if I'm thinking back to my equation that I wrote for this story, y equals 1.5x plus 8, what would be my rate of change, or that amount that I'm adding every time I add a cup? Melina.
1.5.
And why do you think that?
Because x is the number of cups.
Very good, because we're talking about how much are we adding for every x cup. So that number that's attached to our variable, our x, is going to be our rate of change, or our slope. We're going to talk about slope we're going to talk about writing equations tomorrow. Today we're just getting our feet wet with linear relationships. Okay? So our slope is going to be 1.5, and what does it mean in context? Dun, dun, dun. I'm going to keep asking you about that word context. What does it mean in this story, Eden? What does that 1.5 represent in this story? What does it mean, Aiden?
Height that the cup has.
The total height that the stack is?
No, how much one cup is adds to the stack.
Exactly. 1.5, our constant rate of change in this story,
Would the
represents
custodian please go to the
how
Gold
much
Team Boys back room?
one cup adds to the
If
stack.
you need details, give me a call at 3211.
The slope is how much we're adding each and every time. Good. So at what point does our line intersect our vertical axis? So if you continue that line, so we have this one point here. Oh, wow, that was perfect. Okay. This is very exciting, guys. This one's probably not going to be perfect, but so general area here. I'm just recreating it here. Where does it intersect our vertical axis? Look on your graph, which has a straight line on it. Where does our line, our equation line, hit the y-axis or the vertical axis? Brianna, where does it hit? So if we follow it all the way down to the y-axis here, where does it hit? It's not going to be at 8. It's going to be at a little bit below 8. So like, okay. Look at it. Is it at 5? Let's count. 1, 2, 3, 4, 5 would be here. 5 would be a little bit too low. 5, 6. It hits at 7. So where does it hit our vertical axis here? Where does it cross the y-axis? It crosses at 0, 7. And now I want to think about this 0, 7 in the context of this story. Caleb, what does this 0, 7 mean in the context of our story? That 0 what is going to be 7 what? So 0 is our x. 0 what? 0 cups is going to be what? Does that make sense? Is 0 cups going to be 7 centimeters? So this vertical intercept doesn't necessarily make sense in our story, but it still represents, it's still like that's still where it crosses our vertical axis. So how much does each cup, so what does it mean, what does it tell about the cups? 0 cups would be 7 centimeters. But I'm going to put some question marks because that doesn't make sense. That's what it means in the context of the story, but it's not going to, it doesn't really make sense if you're thinking about it. Because 0 cups is not going to have any height at all. So there's a little bit of a conundrum. And then the last question, which we all know the answer to. How much height does each cup add after the first one when you add it to the stack? So every time you add a cup, how much does it add? 1.5 what? Centimeters. Very good. 1.5 centimeters. Okay? So tomorrow, we're coming in, we're looking at the lesson summary for this activity. What I want you to do is I want you to look at for homework tonight. You have 2 things for homework. Listen. You have the exit ticket, which I linked in.
Good afternoon.
And you have 10 problems
At this
on
time,
Alex.
we're going to dismiss
10
red,
problems
purple,
on Alex.
and gold team walkers
If
and
you need
pickup.
help with Alex, let me know.
Also, groups
That is
18,
your homework.
19,
Exit ticket
20,
and Alex.
21, and 22. Please report to the front of the building for dismissal.
Folders you can leave on the desk because I have better ones that I'm going to hand out for tomorrow. Okay, people at home, make sure you know homework tonight. First, exit ticket and the Alex. Homework is an assignment in classroom tonight, so make sure once you get it done, you hit turn in. Does anybody at home have questions? If you don't have any questions, you guys can head out. I will see you guys tomorrow, okay? Ladies and gentlemen, fantastic job today.